All right, happy Monday, everybody who is learning from home for hopefully just the next couple of days, and you can all come back after Thanksgiving or soon thereafter. Today, what we're going to be looking at is putting into effect or working with the vocab terms we learned last week, like genotype and phenotype. Remember, genotype is an organism's genetic makeup. Phenotype is their physical appearance based on their genotype. And the three genotypes, which are, so alleles, first off, we got to remember alleles are two different types of a trait or two different forms of a gene. You can inherit either a dominant or a recessive, one from each parent. And the combination of those alleles is what makes up your genotype. So you could be homozygous dominant for a genotype, meaning that you have two dominant alleles for that genotype. You could be homozygous recessive for a genotype, meaning that you have two recessive alleles for that genotype. Or you could be heterozygous, which means that you have both a dominant and a recessive. Now, one thing we need to remember going into this is that if you inherit at least one recessive allele, one dominant allele, that dominant allele is always going to overpower a recessive. So if you have either a homozygous dominant genotype or a heterozygous genotype, the dominant trait is always going to be exhibited. If you have inherited a homozygous recessive genotype, meaning you have two recessive alleles, that's the only time a recessive genotype gets expressed. Now, we do all of this vocab prepping because today and for the rest of the week and for the next 2 weeks after we come back for Thanksgiving, we're going to be working with a genetic tool called a Punnett square. And a Punnett square is just a way to predict the genotypic or the genetic and the phenotypic, what they'll look like, ratios and outcomes of a genetic cross. So if I cross two people who can roll their tongues, what are the chances that any kids they may have will or will not be able to roll their tongues is basically what we're looking at. So if you guys in your notes would please go ahead and log into page number 22. We're looking at this page right here where it says Punnett squares. We have an example Punnett square right here. So a Punnett square, like I just said in the introduction, is used to predict possible genotypes and phenotypes, so the genetics and the physical appearance of offspring. We do this using both percentages, so what's the percent chance that this is going to happen, and ratios. Okay, and we're going to be working with out of 4. So our ratios are going to be out of 1 out of 4, 2 out of 4, 3 out of 4, or 4 out of 4, or 0 out of 4 in some cases. So the way that a Punnett square works is you're going to get a blank 4 square box like the one you see over here on the right. And then at the top, you're going to put one parent's genotype, okay? One allele per box. So this person has a heterozygous genotype. They have one dominant, one recessive. So this might be, we'll say this is dad, okay? We'll put dad at the top. Mom has, again, a heterozygous genotype, meaning she has a dominant allele and a recessive allele. One allele per box. Now, there's a formatting issue that I want to address with you guys, and I'm going to be very picky about this. Your capital letters always come first, all right? Just like in language arts, you capitalize the beginning of a sentence, you capitalize proper nouns and everything like that. When we do Punnett squares, your dominant allele, if there is one, is always going to come before a recessive allele. All right, so we have our genotypes lined up on the top and on the left, okay? One parent's up here, one parent's over here, one allele per box. So now it's something like, I think you call it the window method in math. It's been a long time since I've been in 8th grade or 7th grade math, so I don't remember. But how this works is you're going to take the genotypes from each parent and you're going to drop them either down into the boxes below them or across in the boxes to the right. So let's start up here with our top genotype, okay? Heterozygous, one dominant, one recessive. And up here, I'm going to grab a dominant A, okay? Because I'm going to take this A right here and I'm going to drop it down into the 2 boxes below it. So 1A goes in this box. I just lost an earring. And 1A goes in the box below it. All right? Same thing goes for your recessive allele over here, all right? It's on the top, so that top allele is going to drop down into the 2 boxes below it. So take my lowercase a up here. I'm going to drop it into this box. And then I'm going to drop it into the box below it. Right? Now, I've done the top ones. I'm just dropping them straight down. The ones on the side are going to come across. So they're going to start on the left, and we're going to bump them into the boxes to the right of them. So I have my dominant allele here, which is going to go into the 2 boxes to the right of it. So I'm going to take another dominant A from up here. I'm going to stick it right there. And then I'm going to take it across to this one. So another dominant allele is going to go right here. And then my recessive allele down here, whoops, if it helps if I stay on the same page. I'm going to take an A, lowercase a from up here, recessive allele. So I'm going to bump it to this box. I'm going to take that recessive allele over into the next box as well. And notice, each box now should have 2 alleles in it. And each box should have its own specific genotype that you get from crossing those alleles from the parents. So now what does this data mean? Well, we figured out what things look like. Oh, shoot. Sorry, my video keeps stinking in and out on me. No, stay on. Thank you. What's going to happen now is I'm going to look at the data that I'm presented with here. I have 2 dominant alleles in this box. So this would be a homozygous dominant genotype. In this box, I have a dominant and a recessive, so this would be heterozygous. Down here, dominant and recessive, this is heterozygous as well. And then my bottom right-hand corner over here is a homozygous recessive because I have 2 recessive alleles. So let's look at the questions that are asked of this cross right here. This is where we're going to start the problem solving. What are the possible genotypes from this cross? So what genotypes do I have? Well, I have a homozygous dominant. Okay, that's this one right here on the top left. I have 2 heterozygous. So top right, bottom left. And I get homozygous recessive, the bottom right. So if red is dominant to white in this cross, maybe these are flower petals, all right? And red flower petals are dominant to white flower petals. If red is dominant to white, so red would be a capital A, white would be a lowercase a. Okay, red is dominant, white is recessive. What are the possible phenotypes? So now we have to look and we have to see which alleles each genotype contains so we can determine what the phenotype is. So if red is dominant to white, so red is dominant. I'm gonna look at this one right here. It has 1 dominant, 2 dominant. So the dominant trait shows through on this one. So that flower is going to be red. On here I have a dominant and a recessive, but even if I have 1 dominant, that dominant is going to elbow that recessive out of the way and it's going to show up, okay? The recessive doesn't get to do anything. Smush it down. It's dominant. So this one and my bottom right one, bottom left, are both heterozygous, but because they have that 1 dominant, even with 1 dominant, that dominant trait shows up. So these both are going to be red as well. This bottom right-hand one has 2 recessive alleles. And remember, if I have 2 recessive, that's the only way that the recessive trait gets to be expressed. So the bottom right one, because there's no dominant red, there's 2 whites, it gets to be white. So back to the question, if red is dominant to white in this cross, what are the possible phenotypes? Well, I have red flowers, right? Anything that has that dominant allele in it is red, and I have white. Now, what percent would be white, would be red? Well, how many of them have a dominant allele in them? 1, 2, 3. What's 3 out of 4? Or think about quarters, okay? 75%. So in a cross between 2 heterozygous individuals, okay, remember they're both heterozygous up here, dominant recessive, I stand a 75% chance of any offspring being or exhibiting the dominant trait. What percentage would be white? Well, this little one right here, there's only 1 out of 4 of them, so that equals out to be 25%. Now, what percent would be heterozygous, meaning it has a dominant and a recessive? Well, it's this top right-hand one, and it's this lower bottom-hand one. Lower bottom hand, lower left-hand one. So that's 2 out of 4 or 50%. So 50% of the offspring would have a heterozygous genotype. What percent would be homozygous? Now, this isn't asking for homozygous dominant or homozygous recessive. It's just asking for homozygous. So what percent of these are going to have the same 2 alleles? Well, we have one right here, it's homozygous dominant, and we have one down here that's homozygous recessive, but they're both homozygous. Okay, they both have 2 of the same. So this one has 2 dominants, this one has 2 recessives. So 50% of those are going to be homozygous. All right. So let's try a couple more of these in practice, and then I will set you guys up for your assignment for today. Oh my gosh, my nose is itchy. So our question up here says, in a certain pepper plant, hot flavor is dominant, so it's going to be represented with a capital H, to mild flavor, which is going to be represented by a lowercase h. If you cross 2 heterozygous plants, what percentage of the offspring will have hot flavor? Now, I've already done this for you in your notes, but anytime you guys get a Punnett square problem, I want you to underline the parents' genotypes. So that way you know what you're working with. You don't have to go searching through the problem for it time and time again to refresh yourself. All right. So here I have underlined heterozygous, and there's 2 of them. So that means that both parents are heterozygous. So in my top boxes up here, I'm going to write a capital H and a lowercase h. Okay. Heterozygous, 1 dominant, 1 recessive. So that's my first parent. My second parent is going to go down the side here. And remember, it's heterozygous again. So 1 dominant, 1 recessive. And then I'm going to start with my top one. So I'm just going to bring that capital H straight down. And then I'm going to start up here with my lowercase h. I'm going to bring that straight down. I'm going to bring my h's across. So I get a capital H here. Oops. And a capital H here. Lowercase h is going to go across to the right. So I get a lowercase h, lowercase h. So this one wants to know what percent of the offspring would have hot flavor. So remember that hot flavor is dominant to dominant. Oh my gosh, I can't do this on a Sunday. A percent that has hot flavor. So hot flavor is dominant over mild flavor, which would be recessive. So any of these boxes in here that have a dominant, at least one, a dominant allele are going to be hot. So I have 1, 2, 3 with hot flavor. So 3 out of 4 gives me 75%. Gosh, dang it, stupid video. I think my cord is loose. Are you okay? I think we're okay. All right. So the percent with mild flavor. So mild flavor is recessive, which means I have to have 2 recessive alleles for that mild flavor to pop up. And that's this little one back here with 2 little h's. So that's 1 out of 4, or 25% are going to have mild flavor. Our next one, brown fur is dominant, represented by a capital B, over white fur, represented by a lowercase b, in rabbits. What is the percent of brown fur in offspring between a heterozygous rabbit and a homozygous recessive rabbit? So again, I've already gone through and underlined your genotypes for you. Okay, but when you guys get to your assignment and everything today, I want you to make sure that you're doing that on your own, please. So heterozygous, I'm going to put that one up top, 1 dominant, 1 recessive. And then homozygous recessive, so homozygous meaning 2 of the same. Recessive means they're both lowercase, they're both recessive. Okay, so little h, little h. And then again, I'm going to bring my h's straight down and straight down. And I'm going to take my recessive alleles, my little h's, I'm going to take them right across. And notice how I'm keeping it so that my capital letters are always up front. That's a formatting thing that we need to make sure that you guys are doing. All right, so the capital letter always goes first. So now the Punnett square is finished. And we want to know what percentage of these rabbits are going to have brown fur. All right. So brown fur is dominant, which means anything with a capital H in it is going to have brown fur, which is only these 2 right here. So that is 50%. Percent with white fur means that both recessive alleles were inherited, which are these 2 right here, top and bottom on the right-hand side, which is again 50%. So I would expect that out of a litter of rabbits between these two parents, 50% of them would be black or brown, 50% of them would be white. Doesn't matter how many rabbits. They had 20 rabbits. I would expect 10 of them to be brown, 10 of them to be white. All right, we're going to do 2 more practice ones. So in this problem, red petals are dominant over yellow petals in flowers. What is the probability and percent of yellow flowers between a homozygous dominant, okay, I'm going to go through, underline that, oops, underline it. A homozygous dominant red flower, capital R, and a homozygous recessive yellow flower, lowercase r. So again, I'm going to underline my genotypes. So one parent is homozygous dominant, which means it has 2 dominant alleles. The other parent is homozygous recessive, which means it has 2 recessive alleles. So again, I'm going to drop my H's down. I'm going to bring my H's straight across. All right, my ratio, I want to know red flowers to white to yellow flowers. So my red flowers, remember red is dominant to yellow, so anything that has a dominant allele is going to be red. Well, 1, 2, 3, 4 have a dominant allele, so that means I have 4 red flowers to 0 yellow flowers. So percent of yellow flowers is 0%. There is nothing in here that has a homozygous recessive gene. And there are 100% red flowers. So this is like the example I gave on Friday when we talked about Mendel and his pea plants when he crossed a purple flower to a white flower. The first generation, he got all purple flowers. Same thing here. If I cross a red flower to a yellow flower, first generation, I get all red flowers because in Mendel's case, the purple was dominant. In our case, the red is dominant. And anytime I have at least 1 dominant allele in there, it's going to bash that little recessive one. Okay, so the recessive allele doesn't get to show up. So these are all red. All right, last practice one in your notes today. Gold horns, denoted by a capital G, is dominant over silver horns, lowercase g, in unicorns. What is the probability and percent of having a silver horn in a cross between 2 heterozygous, underline that, gold-horned unicorns? So heterozygous, again, means you have 1 dominant and 1 recessive allele. So I have 1 dominant, 1 recessive, and they're both heterozygous. So they both get 1 dominant, 1 recessive. All right. So I'm going to bring my G's down. I'm going to bring my G's across. Complete the Punnett square. Now, what is my ratio of gold to silver unicorns? Anything that has a capital G in it is going to be a gold unicorn. So I have 1, 2, 3 genotypes that are dominant. So it's going to be 3. And I have 1 genotype that is homozygous recessive, meaning that that is going to be a silver horn. So 1. 3-to-1 ratio of gold to silver horns. Quit that. So what's the percentage of silver horns? Well, it's 1 out of 4, which to percentages means that it's 25%. The percentage of gold horns, there's 3 out of 4, which means that it is a 75%. Right? So there's our little crash course in working with Punnett squares. I'm going to sign off here, and then I will put up another video attached to your worksheet for today where I'll walk you through that. If you have any questions with this, all right, and you need some one-on-one help, please shoot me an email, and I will try to set up a one-on-one Zoom with you when I have time. So it may be sometime maybe in the evening when I'm out of school because I have a meeting Monday after school at the science department. I can get you during lunch on Tuesday or during brunch on Wednesday, unless you're doing this in the morning, and then I can get you during lunch on Monday, all right? So if you need any help, email me, we'll get you taken care of, all right? So make sure your notes are all filled out with this, and then go ahead and move on to your assignment today, which is posted below, all right? So I'll see you in just a minute.